In this video, we are going to evaluate some trig expressions using sum and difference identities. So all of the identities on this page, all of these formulas, you need to commit to memory. So pause the video, study this sheet until you can reproduce it from memory. Also, throughout the video, I am going to be assuming that you have memorized the facts on this page. So if you do not know these facts, again, pause the video and study this until you can reproduce this page from memory. Alright, take a look at problem number 1. Now, 11 pi over 12 is not a special angle. So I'm going to split this apart using angles like pi over 6, pi over 3, and pi over 4 that I know how to evaluate. Now, one technique that I like to use is subtraction. So I'm going to start with 11 pi over 12, and I'm going to subtract one of my special angles. Let's try pi over 4 and see what happens. So if I wanted to subtract pi over 4, I need like denominators, so I'm going to have to multiply by 3 in the numerator and the denominator. Now, 11 pi over 12 minus 3 pi over 12 is 8 pi over 12. And that reduces down to 2 pi over 3. So therefore, I have 11 pi over 12 minus pi over 4 is equal to 2 pi over 3. Now, if I add pi over 4 to both sides, in other words, moving this to the other side of the equation, then what I'm left with is 11 pi over 12 is equal to pi over 4 plus 2 pi over 3. And this is what I need. So using this equation, I can substitute. So now I can rewrite this. Okay, instead of having the sine of 11 pi over 12, I can write it as the sine of pi over 4 plus 2 pi over 3. Alright, notice that both of these are special angles. Now I can go ahead and use this top identity. I'm going to use this formula right now. So if I want to do the sum, the sine of the sum of these, that should be the same thing as the sine of pi over 4 cosine 2 pi over 3 plus cosine pi over 4 sine 2 pi over 3. Alright, that's what that formula said. Now each one of these I can evaluate using values off of my chart right here. So specifically sine of pi over 4, we know that that is radical 2 over 2. Cosine of 2 pi over 3. Well, let's start with cosine pi over 3. Cosine pi over 3 is 1/2. So that tells me that cosine 2 pi over 3 is either going to be positive 1/2 or maybe it's going to be negative 1/2. So as I think about it, I'm picturing 2 pi over 3 and it's going to look like this. Alright, here's 1 pi over 3. 2 pi over 3 is right here in the second quadrant. Cosine is negative over here because it's to the left. So that tells me to go ahead and go with negative 1/2. Okay, so it's going to be negative 1/2. Let's keep going. Cosine of pi over 4, we know that that is radical 2 over 2. Alright, sometimes I call this 1 over radical 2. That's the same thing. But in this type of problem, it's more convenient to write it as radical 2 over 2. And sine of 2 pi over 3. Again, think about the sine of pi over 3. We know that the sine of pi over 3 is radical 3 over 2. So the sine of 2 pi over 3 is either going to be positive or negative radical 3 over 2. But in the second quadrant, sine is positive because it's a y value, and that is above the x-axis. So I'm going to leave it as positive radical 3 over 2. So multiplying these two together, that's going to give me negative radical 2 over 4. Okay, multiplying these two together, let's see, radical 2 times radical 3 is radical 6. Alright, so that's radical 6 over 4. And oh look, I have like denominators even. So that's going to give me negative radical 2 plus radical 6 all over 4. And that is the answer. Now for problem number 2, we are given degrees. And really I would rather work with radians. So the first thing I'm going to do is I'm going to take 195 degrees and I'm going to convert it to radians by multiplying by pi over 180. So basically I just need to reduce this. So if I divide the numerator and the denominator by 5, let's see, 195 divided by 5. That's 39. So I've got 39 pi. 180 divided by 5 is 36. So I've got 39 pi over 36. Now both of these are definitely divisible by 3. So let me go ahead and do that. So that's going to give me 13 pi over 12. Okay, so now I have radians. So this original problem would be the same thing as having the cosine of 13 pi over 12. Alright, so I'm going to just go from there. Okay, now I need to split this apart into special angles. So I'm going to try my subtraction method again. So let's see, 13 pi over 12. Let's try minus pi over 4 and just see what happens. To make like denominators, I'm going to have to multiply by 3. So, interesting. I have 13 pi over 12 minus 3 pi over 12 is going to give me 10 pi over 12. This is going to reduce down to 5 pi over 6. So that means 13 pi over 12 minus pi over 4 is equal to 5 pi over 6. Now, adding pi over 4 to both sides, I have 13 pi over 12 is equal to pi over 4 plus 5 pi over 6. So this is the equation I'm going to use to split this apart. So I should be able to rewrite this in the following way. The cosine of pi over 4 plus 5 pi over 6. Alright, these both involve special angles that I can evaluate without a calculator. Okay, so now I need to use my sum and difference formulas. So I'm going to use this formula right here, the cosine of something plus something. Okay, so according to that formula, I should be able to write this as the cosine of pi over 4 cosine 5 pi over 6 minus, notice the sign change, okay, sine pi over 4 sine 5 pi over 6. So let's just evaluate each one of these in turn. Cosine pi over 4. We have memorized that that is radical 2 over 2. What about cosine of 5 pi over 6? Well, forget about the 5 for a second. What's the cosine of pi over 6? Cosine of pi over 6 is radical 3 over 2. Right? We know this from our chart. Cosine of pi over 6 is radical 3 over 2. So the thing is, the cosine of 5 pi over 6 is either going to be positive radical 3 over 2 or negative radical 3 over 2, just depending on the quadrant. So here's a diagram for you. Alright, we're talking about a reference angle of pi over 6. So here is a diagram of pi over 6's. Okay, so these are the angles. Well, you know what? Let me not say it that way. We're talking about 5 pi over 6. So where is that? So let's see. This is 6 pi over 6. 5 pi over 6 is right here. So the question is cosine positive or negative in this second quadrant? Negative. Cosine is the x value, and x values are negative over here to the left. So that's why I'm going to go with a negative radical 3 over 2. Let me just put it in the middle. Okay, so negative radical 3 over 2. All right, back to business. Sine of pi over 4, that is radical 2 over 2. Sine of 5 pi over 6. Again, this is 5 pi over 6. The sine of pi over 6 is 1/2. Alright, that's the reference angle. So the sine of 5 pi over 6 will either be positive 1/2 or negative 1/2. Sine is positive in the second quadrant because it's a y value and that's above the x-axis. So I'm going to leave it positive 1/2. Okay, now let's just multiply and search. So if I multiply these together, I am going to get negative radical 6 over 4. If I multiply these together, I'm going to get radical 2 over 4. Now, these have like denominators, so I can go ahead and put these right together. So this is going to be negative radical 6 minus radical 2 all over 4. You know, let me just bite the bullet and scroll. So this is the final answer. Alright, and there you go. That's how you do it. Okay, let's go. So this time we have radians to start out with, but I need to split it apart into special angles. So I'm going to try my subtraction method again. So if I do 5 pi over 12, and I'm going to go ahead and subtract pi over 4, and let's see what I get. To have like denominators, I need to multiply by 3 in the numerator and the denominator. So here I have 5 pi over 12 minus 3 pi over 12. That's going to be 2 pi over 12. But that reduces down to pi over 6. So that tells me that 5 pi over 12 minus pi over 4 is equal to pi over 6. Now adding pi over 4 to both sides, that gives me 5 pi over 12 is equal to pi over 4 plus pi over 6. So this is the fact that I will use to split these apart. So this is the same thing as having the cosine of pi over 4 plus pi over 6. Alright, so I will use this for the rest of the problem. Okay, cosine of something plus something. So remember that this is the formula that we will use for that. So here we go. So I should be able to rewrite this as the cosine of pi over 4 cosine pi over 6 minus, notice the sign change, sine pi over 4 sine pi over 6. Okay, so let's evaluate each one of these separately. Cosine of pi over 4. We have memorized that this is radical 2 over 2. Cosine of pi over 6, we have memorized that this is radical 3 over 2. Sine of pi over 4 we know to be radical 2 over 2. And the sine of pi over 6 we have memorized is 1/2. Multiplying these together, we have radical 6 over 4. Multiplying these together, we have radical 2 over 4. Since we have like denominators, we can combine these and we get radical 6 minus radical 2 all over 4. So this is the answer to number 3. Alright, number 4. Now we have tangent. This should be fun. But let's start by finding the special angles that we can use to split this apart. Let's try our subtraction method again. So we have 17 pi over 12. Let's go ahead and subtract pi over 4 and see what we get. To get like denominators, I'm going to need to multiply by 3, numerator and denominator. Okay, so 17 pi over 12 minus 3 pi over 12 is going to be 14 pi over 12. So, well, that's going to reduce down to 7 pi over 6. So that tells me that 17 pi over 12 minus pi over 4 is equal to 7 pi over 6. Now, adding pi over 4 to both sides, thus moving it over to the right side of the equation, is going to give me 17 pi over 12 is equal to pi over 4 plus 7 pi over 6. So this is the fact that I'm going to use to split this apart. Okay, so I should be able to rewrite this as tangent of pi over 4 plus 7 pi over 6. Okay, tangent of something plus something. That is going to be right here. take a gander at this formula and make sure you have it committed to memory. Okay, so according to that formula, I should be able to rewrite this as the tangent of pi over 4 plus the tangent of 7 pi over 6. Alright, all over 1 minus tangent pi over 4 tangent 7 pi over 6. Okay, tangent pi over 4, that's something that we have memorized. Tangent of pi over 4 is 1. So I'm going to have 1 plus. Now we need the tangent of 7 pi over 6. Well, let's start with the tangent of pi over 6. We know that the tangent of pi over 6 is radical 3 over 3. Okay, that is one of those things that we have memorized. Tangent of pi over 6 is radical 3 over 3. So that means the tangent of 7 pi over 6 is either going to be radical 3 over 3 or it might be negative radical 3 over 3. It's going to be one of those. So which one is it going to be? Let's look at a diagram to help us know. Okay, it just depends on the quadrant, really. Okay, so here comes a diagram of pi over 6's, which are a little bit tricky to draw. Okay, that was pretty bad, but I'm just going to keep on going. So here are a bunch of pi over 6's. Now 7 pi over 6. So look, here's 6 pi over 6 is right here. 7 pi over 6 is right there in the third quadrant. Now tangent is positive in the third quadrant. So that just tells me that I'm going to stick with the positive radical 3 over 3 version. Okay. Okay, so I had a tangent of pi over 4, that was 1. Tangent of 7 pi over 6, that's radical 3 over 3. Now I'm working the denominator. So in the denominator here I have 1 minus. Okay, tangent of pi over 4, remember that's 1. So really I don't really need to write anything down because it's just a 1. I'm going to wind up erasing that in a minute. But then I have the tangent of 7 pi over 6. We just talked about the fact that that is radical 3 over 3. Okay, so I'm just going to erase this and I'm just going to put radical 3 over 3. So really this is one form of the answer right now. Okay, we can get another form of the answer if we rationalize the denominator. Here's how you would rationalize the denominator. You would have to multiply by something called the conjugate, which is really just changing the middle sign here. So instead of 1 minus radical 3 over 3, I would multiply by 1 plus radical 3 over 3. And I would do that in the numerator as well. Okay, if you FOIL this out, double distribute, whatever you want to call it, 1 times 1 is going to give me 1. The inner and the outer is going to cancel out. Then I will wind up multiplying these times each other. So this is going to give me negative, because a negative times a positive is negative. Radical 3 times radical 3 is 3. 3 times 3 is 9. So it's going to give me that. Meanwhile, in the numerator, if I multiply these together, I'm going to get, let's see, 1 Then inner, I've got radical 3 over 3. Outer, I've got another radical 3 over 3. So that's 2 radical 3 over 3. And then in the end, when I multiply these together, again, I'm going to get 3 over 9. This time it's going to be positive 3 over 9. Okay, now of course 3 over 9 reduces down to 1/3. So I think I'll just go ahead and erase the 3 over 9s and put 1/3. Okay, like denominators though, guys. So 1, see this 1 right here and this 1 right here. Would it amaze you if I replaced 1 with 3 over 3? Alright, both of them. That way I have like denominators. So I have 3 over 3 plus 2 root 3 over 3 plus 1 over 3. And then down here I have minus 1 over 3. Like denominators everywhere. It's a beautiful thing. So in the numerator, let's see. I have 3 plus 1, so that's 4. Okay, and then I've got the 2 radical 3. Alright, and that's over the like denominator of 3. Now in the denominator I have 3 minus 1, so that's 2 over 3. And of course when you divide a fraction by another fraction, you multiply by the reciprocal. So I'm just going to take this up over here. So I'm going to wind up with 4 plus 2 root 3 over 3 times, now here comes the reciprocal, 3 over 2. Now these 3's cancel each other out. So I wind up with 4 plus 2 radical 3 over 2. Now this 2 is going to wind up dividing separately under each one of these. So it's going to be like this, 4 over 2 plus 2 root 3 over, that's a 3, over 2. Alright, this 2 divides evenly into both of these. So I'm going to wind up with 2 plus radical 3. Now that was a lot of work, but I think you'll agree that this is a much simpler form of the answer. It's a superior, more elegant answer, 2 plus radical 3. So that is the other form, 2 plus radical 3. That is the better form of the answer. Alright, number 5 is given to us in degrees. I prefer to work in radians, so the first thing I'm going to do is I'm going to take this negative 15 degrees and I'm going to turn it into radians by multiplying by pi over 180. So essentially I just need to reduce this. So both of these are divisible by 5, so I'm going to go ahead and do that. So that's going to leave me with negative 3 pi over 36. Now both of these are divisible by 3, so I'm going to do that. So that's going to leave me with negative pi over 12. Negative pi over 12. So negative 15 degrees is the same thing as negative pi over 12 radians. So I'm going to go ahead and write it that way instead. Alright, so this is the same thing as having the tangent of negative pi over 12 radians. Okay, so now I'm going to keep going and split this apart into special angles. And I'm going to try my subtraction technique again. So let's see. I have negative pi over 12, and I'm going to go ahead and subtract pi over 4 and see what happens. Now, in order to subtract these, I need a like denominator, so I'm going to multiply by 3. Okay, so what do I have here? So I have negative 1 pi over 12 minus 3 pi over 12 is going to be negative 4 pi over 12. Of course, this reduces, so this is going to be negative pi over 3. Okay, so that tells me that negative pi over 12 minus pi over 4 is equal to negative pi over 3. Adding pi over 4 to both sides, and thus moving it to the right hand side of the equation, gives me negative pi over 12 equals pi over 4 minus pi over 3. Interesting. So I am going to rewrite the problem using this fact. So this problem is the same as having the tangent of pi over 4 minus pi over 3. Alright, so now I've rewritten it using special angles that I can evaluate. Okay, now I need the formula. Tangent of something minus something. What's up? Alright, here's the formula right here. Soak it in. Soak it in. Alright, now let's use it. So, according to the formula, this should be the same thing as the tangent of pi over 4 minus the tangent of pi over 3 over 1 plus tangent pi over 4 tangent pi over 3. Okay, let's do all of these pieces. Now, here comes the fraction. So tangent pi over 4, we have memorized that that is 1. Tangent pi over 3, that is radical 3. Alright, I'm just quoting facts off of the sheet that we have memorized. Tangent of pi over 3 is radical 3. Okay, so that's the numerator. Now the denominator, I have this 1 right here, and then plus. Tangent of pi over 4 is 1. I'm not even going to write that down because it's just 1 times whatever is coming. It's not going to change anything, so I'm not going to put it. But tangent of pi over 3, as we said, is radical 3. Okay, so look, this is one form of the answer. It is not the best form of the answer, but it is one form of the answer. The best form of the answer is the form that you will get if you rationalize the denominator. So again, if I have 1 minus radical 3 over 1 plus radical 3, here's how you rationalize the denominator. You're going to multiply by the conjugate. So the conjugate here would be 1 minus radical 3. The conjugate of the denominator. So I'm specifically looking at the denominator. And then the numerator, I just have to do the same thing. So 1 minus radical 3 again. If I multiply this out, okay, focusing on the denominator, 1 times 1 is 1. Inner plus outer equals middle, but inner I have 1 radical 3, outer I have negative 1 radical 3. Those cancel each other out. So I'm going to skip to the end. positive radical 3 times negative radical 3 is going to be negative 3. Radical 3 times radical 3 is 3. So I've just got 1 minus 3. Now up here, first I have 1 times 1, so that's going to be 1. Now inner plus outer equals middle. Inner, I have negative radical 3. Outer, if I multiply these, I get negative radical 3 again. So together that's negative 2 radical 3. And then I have negative radical 3 times negative radical 3. That's going to be positive 3. Alright, a negative times a negative is a positive, and radical 3 times radical 3 is 3. So, like terms and such. Alright, I have 1 plus 3, so that is going to be 4 minus 2 radical 3. 1 minus 3 is negative 2. Okay. Now, negative 2 divides evenly into both of these terms. So this is going to be like having 4 over negative 2, and then minus 2 radical 3 over negative 2. Okay, so what am I going to have? So here comes the other form. Obviously, 4 divided by negative 2 is negative 2. Okay, a negative divided by a negative is a positive. So I'm going to have negative 2 plus something. Okay, so those cancel each other out though. So I'm just going to have negative 2 plus radical 3. Alright, because this makes like negative 1 and minus negative 1 is positive. Boom, here you go. Alright, that is it. Alright, this video is very long, but we are going to do one more problem on this video. So we are given degrees, so I want to change this to radians. So I'm going to take 105 degrees, and I will turn it into radians by multiplying by pi over 180. Both of these are divisible by 5. So I'm going to do that. This is going to make 21 pi. Alright, 105 divided by 5 is 21. And this is going to make 36. Alright, 180 divided by 5 is 36. Now both of these are divisible by 3. So I'm going to do that. So that's going to make 7 pi over 12. Okay, so now I have radians. So this problem would be the same as having sine of 7 pi over 12 radians. Alright, so I'm going to use this for the rest of the problem. Okay, now I need to split this apart into special angles. So I'm going to try my subtraction method once again. So if I have 7 pi over 12, and I'm going to try subtracting pi over 4, because that's worked for me very well so far. What will I get? Well, in order to do this, I need like denominators, so I would need to multiply the numerator and denominator by 3. So 7 pi over 12 minus 3 pi over 12 is 4 pi over 12, which reduces to pi over 3. That means 7 pi over 12 minus pi over 4 is equal to pi over 3. Adding pi over 4 to both sides, that tells me that 7 pi over 12 is equal to pi over 4 plus pi over 3. Okay, so this is the fact that I'm going to use to split this apart into special angles. So this is the same thing as having the sine of pi over 4 plus pi over 3. Awesome! Alright, sine of something plus something. What's up? Okay, we're just using this formula right here at the top. Make sure you have it memorized. So according to that formula that I just showed you, I should be able to rewrite this as the sine of pi over 4 cosine pi over 3 plus cosine pi over 4 sine pi over 3. Okay, these are all facts that we have memorized. So sine of pi over 4 is radical 2 over 2. Cosine pi over 3 is 1/2. Okay, cosine of pi over 4 is radical 2 over 2. And sine pi over 3 is radical 3 over 2. Multiplying these two together gives me radical 2 over 4. Multiplying these together gives me radical 6 over 4. Considering that we have like denominators in everything, that gives us radical 2 plus radical 6 over 4. Easy peasy lemon squeezy. Alright, that's going to do it for this video, guys. I hope it was helpful, and I look forward to seeing you on the next video.